Alright students, how are you? I just wanted to do another quick example of a longest path problem. It's from your textbook. It's on page 423. It's in exercise 15D. And it's question 1. Shortest path problems, we've got an algorithm. It's on page 422 of your textbook, or on the OneNote page labelled longest path problems. These are the steps. I suggest you have them in front of you as I go through this. Let's get straight into it. First step, label the starting node 0, and then find an unlabeled node that is only accessible from nodes that are labeled. So I'm going to start with here, label this one 0 at our start. And next step, step 2, is find an unlabeled node that is only accessible from nodes that are labeled. Another way to think of that is find a node that doesn't have a label, and you can't get to it using unlabeled nodes. So this one here, for example, I'm not ready to label this one because there's this root here that isn't labeled that I can use to get to it. I'm not ready to do this one yet. But this one here, for example, the only way I can get to that node is from that edge there. And because this edge leaves from a labeled node, I'm ready to label this one. And what I label it with is the maximum length possible to get there. That's easy because there's only one way to get there. And it's along this edge that's worth 12, so that's 12. Up here's the same. There's only one way to get there, so I label that 4, because this edge is worth 4. Let's check. Am I ready to do this one in the middle yet? Well, this root is now labeled. That root leaves from a labeled node. That root leaves from a labeled node. But this root coming on here leaves from an unlabeled node. So I'm not ready to do this one yet. But I am ready to do this one. Now there's only one way to get to this node, and it's this root up here. So it's this 4. 4 plus 3 is 7. Am I ready to do this one? No, because we've got an edge coming in here off an unlabeled node to get there. Not ready to do that yet. But this one here in the middle, now every single root that gets to that node is labeled. Leaves from a labeled node. So I'm ready to do it in now. Let's go through them all. So it takes 7's the maximum to get here, plus another 4 to get to the middle, so that's 11. So 11's my highest. Yeah, I'm gonna write this here on my scratch paper so I remember. 4 plus 2 is 6, less than 11, not interested. 0 plus 7 is 7, less than 11, not interested. But 12 plus 7 is 19, which is bigger than 11. 19's the maximum, so I'm going to write 19 in there. Let's see, next one, there's only 2 ones left. This is only accessible through labeled nodes, so I'm ready to do this one. 12 plus 9 is 21, but 19 plus 11 is 30. And then my last node, my final node, I've forgotten to put in a weight there for some reason. That's 6. 7 plus 4 is 11. 19 plus 6 is 25. But 30 plus 10 is 40. That one's going to be labeled 40. Now, as soon as you label your finishing node, you're done. You can go to step 5. Which step 5 is backtrack through and work out which way is the longest. The way you backtrack is go, okay, this is 40. I know that's the longest route. How did I get to that 40? 40 take 4 is 36. Can't be that one. 40 take 6 is 34. Can't be that one. 40 take 10 is 30. That's it. So I know I went down there. 30 take 11 is 19. Quick check. 30 take 9. No, definitely not 21. 30 take 11 is 19. That's the way I went. 19 take 4. Nope. 19 take 2. No. 19 take 7. Nope. 19 take 7 is 12. Fantastic. went down there. There's only one option here, up this way, and that's your longest route for a total of 40. Down here, up here, up here, up here. Fantastic. Thanks for watching, guys. Bye.